Okay, so lesson 3 here is solving equations involving multiple angles. So what it means by multiple angles is now there's a b value different than 1, so we've had a horizontal stretch. So this changes our algebraic approach. It also changes our general solution, because instead of now adding 2 pi n to our sine and cosine solutions, we're going to have to adjust what we add based on what the period of the equation is. So this first part of this is an exploration, which we kind of did in class, so I'm not going to go through this in the video. We can look at example 1. So given tan of 2x equals root 3 between 0 and 2 pi, find the exact values of x using a graphical approach. So this is the same thing as any other graphical approach. You can graph tan of 2x, and we get our little graph here between 0 and 2 pi. So I believe this is 2 pi here, and it continues this way too, but we just need it between 0 and 2 pi. And find the solutions here. So we just have to find all the spots. I think I drew this incorrectly. We should have one more here. Find all the spots between 0 and 2 pi. There's 4 solutions here. If it wants it as exact values in radians, you would first need to find them in degrees and then convert them. But we do get the values. Pi over 2, or pi over 6, so 30 degrees. 2 pi over 3. 7 pi over 6. And 5 pi over 3. So again, you could find these in degrees using exact values on your calculator, then just change them. The general solution is where this changes. So the general solution consists of answers which differ by, in this case it would be pi over 2 radians. Remember that the degree of the tan graph is usually pi. This has a horizontal stretch of 2, so we multiply all those values by 1/2. Giving me that this graph has a period of pi over 2. So my solutions here are pi over 6 plus pi over 2n. Now again, you could write this out for each of these solutions, but you should find that they actually overlap. Pi over 6 plus pi over 2 is 2 pi over 3. Add another pi over 2, you're at 7 pi over 6. So it's really describing all of them. It's a little unclear whether you'll actually get a question like this on your diploma exam. The curriculum states we don't need to do transformations of tangent graphs. Technically, this is applying a transformation of a tangent graph to find the general solution. So it's unlikely we will see that you have to find the general solution for one of these equations, but it would definitely be fair to ask for just the solutions in a certain domain. So we're going to skip this investigation. We're going to go to the example and the notes on the next page here. So solving these algebraically, there's some steps here that we found out we can use. So you can find the domain for the multiple angle, solve for the multiple angle between 0 and 2 pi using the cast rule and reference angle, add the period of the trigonometric graph of the multiple angle to each of the answers to cover the domain in step 1. So let's see what that looks like when we solve an equation. So we need to solve sine of 2x equals negative 1/2. So we're going to basically just start by solving sine of u equals negative 1/2, and I'm going to solve for u. So where do I need to be for negative 1/2? Well, sine is negative in quadrants 3 and quadrants 4, and it gives us a reference angle of pi over 6. Or 30 degrees. So you could use your unit circle, you could use sine inverse of 1/2, it's going to give you 30 degrees, which is pi over 6. So that means u equals pi plus pi over 6, so that's 7 pi over 6. And it must equal, this would be 12 pi over 6, so it's 1 back 11 pi over 6. Okay, so those are my solutions for this equation. But u was really 2x. So now I need to divide everything by 2. Okay, but something has happened here. Now, notice that I only have solutions between 0 and pi, and I need to get solutions between 0 and 2 pi. So in order to do that, I'm going to add the period of this function to each of these solutions. And that's going to account for the rest. So I know that the period is 2 pi over b. The b value here is 2. So this means I have a period of pi. So if I add pi to this solution, 7 pi over 12 plus pi is going to give me 19 pi over 12. So if you're confused how to do that, you can make a common denominator. So 7 pi over 12 plus pi, I can make a denominator of 12. Add these up. 7 pi plus 12 pi is 19 pi over 12. You could also use your calculator. You could add 7 over 12 plus 1 is going to give you 19 over 12, and then put the pi back in. So the next one, 11 pi over 12 plus pi. In your calculator, you can go 11 over 12 plus 1 is going to give you 23 over 12. Put the pi back in. So that covers all your solutions now. B, state the general solution. Well, the general solution is we're going to take those first two over 12, plus we're going to add the period of the graph here, which was pi in this case, where n is an integer. For these, rather than working with domains and converting things, I often find it simpler to, even if you're asked to solve this algebraically, graph it so you know how many solutions you're looking for, so that once you find these values here, you know how many times you have to add pi on to cover the domain it gave you. Complete the following statement. The general solution consists of answers which differ by pi radians, because the graph of y equals sine of 2x has a period of pi radians. So now, since the period is pi radians, in that domain of 0 and 2 pi it gave us, we know we're going to get all of these solutions twice, which would be another thing that would tell us we should have 4 solutions in the end. Because we got these 2 solutions from one full rotation or one full period or cycle, we know we're going to go through 2 in the domain between 0 and 2 pi, which tells us those solutions are going to repeat. Didn't know that. Okay, so I just got excited because this picture was in color here. So use the distance above the ground of a student on a circular Ferris wheel is given by the equation h of t equals -4 cos pi over 12t plus 5, where h is the distance above the ground in meters and t is the time in seconds when the student is at the lowest point on the ride for the first time. So determine the time it takes the Ferris wheel to make one complete rotation. Well, this is really just saying what is the period of this cosine function. Well, remember, word problems are almost always in radians, so unless you see a degree symbol in there, you want to assume that you're working in radians. So to find the period, always 2 pi divided by the b value, which is that number there, that is our horizontal stretch. And this gives us a period of 24. So it takes 24 seconds to do a complete rotation. B, algebraically determine the times during the first minute of the ride when the student is 7 meters above the ground. So it told us that h of t was the height, so that's 7. And then I'm going to use this formula here. They gave me -4 cos pi over 12t plus 5. Now, I don't think I've ever seen a question on a diploma exam like this that you had to solve algebraically. Usually this is one that I would go right to the calculator for, but we can solve it algebraically. So I first need to get that cosine function by itself, so I'm going to subtract 5. Divide by 4, and I get -1/2. Now I'm going to solve this really pretending that I don't have this pi over 12t in there. I'm just going to pretend maybe that's an x, and I'm going to find the reference angles. Well, cosine is negative here and here, so that's quadrants 2 and 3. If you go inverse cosine of 1/2 in degrees, you're going to get 30 degrees, which is pi over 3. Sorry, 60 degrees, which is pi over 3. Or you could use your special triangle or your unit circle to find the reference angle is pi over 3. So this tells us that the pi over 12 times t is equal to, well, the angle in quadrant 2 would be 2 pi over 3, and the one in quadrant 4 would be 4 pi over 3. And now I got to work on getting t by itself. So you could start by multiplying everything by 12 and then dividing by pi, or you could do it in one step by dividing each of these fractions by pi over 12. Either way, this is just going to give you the numbers 8 and 16. So if you think of it as multiplying everything by 12, you'd get 8 pi and 16 pi, and then when you divide everything by pi, the pi's go away. But it wants to know the number of times this happens in the first minute. So it happens once on the way up and once on the way down, so it makes sense we have two answers here. But then it keeps going around and around, so we want to know how many times in the first minute it happens. So we're going to keep adding on that period of 24 seconds. So 8 plus 24 means we're going to be back in that same spot at 32 seconds. 16 plus 24 tells me we're going to be back there at 40 seconds. Then we add another 24 onto this 32, which gives us 56. Okay, so these answers are all in seconds. I stop after the 56 because it was just asking for in the first minute. So you could keep going with this if you wanted to give it for an infinite amount of time, or if it said up to 5 minutes, you would just keep going. So verify the results graphically would be the same thing. I would graph the 7 and F2 or F1, graph this equation. You would want to make sure you are in radians this time, because this equation only works in radians. But it's okay because these don't need pi in them, so it's going to give you your answers there.